Hey, Nathan here, welcome back to another C++ tutorial. And in this tutorial we are going to discuss classes in C++. So that also includes header files. Alright, so a header file just explains what a class does. It lists all of its public fields, public functions, private functions, all of its pointers, its constructor, its destructor, just what the class contains and what it has. The implementation C++ file actually says how they work. How does this add function work? How does this set value function work? How does this display message to user function work? How does it do its thing? So let's take a class called math. And all we want in that math class is an add function that adds two integer values, x and y. And it returns an integer value. In the header file, it will just say, we have an add function, that's it. In the implementation file, the C++ file, it will say, the add function has this code in it, and all it has is return x plus y. So before we get into my example here, let's talk a little bit about the compiler. Because you might be thinking, well, why do we need a header file and a C++ file? And the way that the compiler works is every C++ file, CPP file, has no knowledge of the other CPP file. There's two phases to the compiler. The first part is to create object files. Out of all the CPP files and everything in our code, it creates object files. The second part is to link all those object files together to create one single result. Either a DLL, executable, or whatever we have in mind. So at that point, everything is known to the program because they're all linked together. But before we reach compile time, we do not know that there's an add function. So that's why we need header files. So let's go ahead and get started and create a header file. So I created a project here that was an empty project, and just like we did in all the other C++ tutorials, I created a main.cpp file and I added the include IOStream using namespace std, and I created the main function here. So let's open up the Solution Explorer and let's right click header files and let's go to add new item. It's going to be a header file and let's call it player. Alright, so we have a player.h file in our header files folder. So let's close the Solution Explorer and let's go ahead and start coding. So in order to create a class, we need to obviously have the word class. And the class in my example is just called player. It's usually appropriate to name the header and CPP files whatever your class is called. So we have a class and then player, then we have an opening curly bracket, and then we have a closing curly bracket. Now we also need to add a semicolon after the closing bracket, and we'll get into that in a few minutes. So like I mentioned earlier, a class can have private fields, private functions, public functions. So it's a good idea to keep everything we can private. And we separate these two by having the statements private and public. So this is saying this is a private section. Here we go. What's included here is private. We want an integer to have the health. Now, why do we want that private? Why do we want to limit ourselves to... Why do we want to restrict everything by default and only give access if we need to? It's a good idea in class design to do that. You do not want to give a bank application full rights to a employee's or customer's balance. You want to have that a private field, and that will be a double, of course, because you can have decimal points, for 50 cents, for example. So that will be a double field, and that needs to be private. You do not want to give the whole bank application, full rights to that balance value. Instead, you do not want to have full rights from that. Instead, you want to have a function to deposit or withdraw from that balance. You do not want to have a full modification rights. You just want to have a deposit and withdraw function. So you don't want to have balance is equal to balance minus 50 in somewhere else in your code. You want to do that on the class level. So you just want to expose deposit and withdraw. The same thing here. We have a player that has health. Nobody else but us needs to keep aware of our health. Now, if somebody hits us, we need to have a function to damage our player. Or if we get healed by a potion or another player, we need to have a function to heal us. So we keep our health hidden, but we expose damage and heal functions. Those are public. Those are exposed to our program. Anywhere we have access to our player class has access to our exposed fields, methods, functions, just whatever we have in our public section here. So, first thing we want to take health away from us, so that's called damage. So we take X amount of damage, and the next one is void heal. We heal X amount of health. Okay, that's it for the header file. Now let's open up our Solution Explorer again. Let's right-click our source files, and let's go to Add, New Item, C++ file, and let's call this player. So it'll be player.cpp. Now we need to pound include our header file, player.h. And we include by using quotes. That means that's in our solution. We made that header file. It's in our solution. The brackets here, where IOStream is wrapped around brackets, the less than or greater than, the angled brackets, those means that include file, that file is in our C++ directory. And you can go into the settings and you can change where it looks for these files. But if we make the header files in our solution, we wrap them in quotes. So we include our player.h file. Now, so we know what the player has. It has a function for damage, it has a function for heal, and it has a private integer for health. Now, how do we actually damage our player, and how do we actually heal our player? That's where we put these in our C++ file. The header files just say what the class contains. Our CPP files say how the class works. So if we look at our header file, void damage int x. So let's work on damage here. So void, we need to code the damage function. So we need to provide the class first, void player, colon, and it gives us our values here. We want to code the damage function first. So damage int x, opening and closing curly brackets here. So when we damage it, we just say health is equal to health minus x. So that's all we need to do for damage. No, we keep our health separate. We keep our health hidden. We just expose the damage and the heal functions. And we do the same thing. Void the class name, colon, and our function name, heal int x. Health is equal to health plus x. Go ahead and save that. So that's all we need to do. As you can see, our CPP file tells us actually how the damage function works, how the heal function works. The header file just says this class contains a function called damage, a function called heal. How does it work? I don't know. I'm just a header file. CPP file says, oh, this is how they work. We just add X to the health if it's a heal. We subtract X from the health if it's a damage. So I know what probably some of you are thinking. How do we initially set the player's health? You know, when you are playing a game and you spawn, you have 100% health. So how does that health get set to your player? It's private. We can't set it. It's only available in the class level. It's not exposed anywhere else. It's a private field. So how do we set it? There's two ways you can set it. The most common way is to have a constructor. And a constructor it constructs your class. It constructs your object. Now the constructor is usually empty. When you call the constructor, you don't pass in anything. You can customize it to where you need to accept certain parameters. The other way to do this is to have an initializer. Now it's up to you to decide what does what. You know, some classes, take my DirectX series for example, there's some classes that have both a constructor and initializer. Because there's just way too much stuff to provide in the constructor. So we split that up and say initialize does this too. So all we need to do is health. So you need to think about when you create a player, what does it absolutely need? Of course it needs health right away, so that needs to be in the constructor. Usually physics and statistical data are in the constructor. You know, the player's position is in the constructor. The player's health is in the constructor. And usually everything after the fact, like graphical data, like the sprite the player uses, is in the initializer or load content, if you have that functionality. So let's discuss the constructor, since that's what we will be using. Physics and statistical data go in the constructor. So the constructor is just the class name, player, and we're back in the header file. Opening parentheses, and any parameters we want to have for the constructor. You can have an empty, parameterless constructor. But we need to have some way to set the health. We do not want to expose a setter because that's just giving us full rights to the health object, health variable. So we'll just say the constructor int health. Now let's go back to the CPP file, and the same way, let's go to the very top, and before the damage function, it's going to be our class name, player, : and our constructor name, which is just our class name, opening parentheses, int health, opening closing curly brackets here. So that's our constructor. Now we need to say health is equal to health. But wait. Our health private field is that. Our parameter and argument is named the same thing. There's two ways you can go around this. A lot of people like the underscore and text for the private data. A lot of people like that. A lot of people like the underscore health, underscore, just underscore name for the private field. A lot of people like that. And that's a nice way to separate it. Underscore health is equal to health. A lot of people like that. Now, if you do not like that, and that's actually recommended by some of the code validators, like in regard to C#, there is a code validator and a add-on called ReSharper. A lot of people use it for code validation and making your code look better and operate better, more efficiently. A lot of people use that for that purpose, and that's one of the things it recommends. Now, if you do not like that, there's of course another way to do this. There is a keyword in C++ and other languages called this. In Visual Basic, it's called me. This refers to this object. When we create a new player, we are creating what's called an object. An instance of a class is called an object. If we go to the header file, health right here is referred to as a variable. Now, we mentioned that in the early tutorials, and I briefly discussed objects and instances. Int health. Health is referred to as a variable here. When we have player Jonathan, Jonathan is an object of the class player. It's an instance of the class player. So this, the keyword this, refers to this object or this instance. And this arrow, health, refers to this object's health. So that's the second way to do that. If you don't like the underscore, a lot of people don't. I'm not a big fan of it myself. This is another way to get around it. No, if the parameter of the function has the same name as the field in your class, if those two are the same name, a way to get around it is to have a keyword that signifies this current object, this instance, and get that field, that variable. That way it'll differentiate between the object level variable and the variable we pass into the function. So the keyword this refers to this current object. So if we have a player X and a player Y, and we call X's constructor, and we pass it 50 for the health, this arrow health will refer to the X's health variable, where this health refers to the 50 health we pass into the constructor. Alright. There is one more thing we'll get into later on, and that's called Destructors. You mostly need this when a class references other classes, and that's what we use for memory cleanup. You can use it for all sorts of things, but when you just have an integer health, you don't need it for that purpose. Alright, before we get started with our implementation, let's go ahead and add one more function, and that's to get our current health. So that's going to be public. It's going to be exposed to anywhere we have access to the player object, and it needs to return the same type as our health, which is integer, and we'll call this get health. It's going to be empty function, no parameters, no arguments, and then that's it. It's going to return an integer. Now let's go to player.cpp, and let's go ahead and code that. It's not going to be void. It's going to be int player : get health. Opening, closing parentheses, opening curly bracket, return health. Closing semicolon, and that's it. Now that's okay. We can have a way to see our health. Just if we think about a banking application, it's okay to see your balance, but it's not okay to have full rights to modify it. We do not have full rights to modify our health. We just have a way to damage and heal ourselves. There's no way we can say health is equal to X. We have health is equal to health minus X. Health is equal to health plus X. Okay, so now let's go back to the main.cpp file and let's implement this and actually use this class. Alright, let's go to the main.cpp file and let's start getting to work. Okay, inside the main function here, we want to reference our player. So we need to include at the top our header file. Remember, everything gets linked to at the end. We'll get one executable or one DLL if we're using a class library. Everything gets referenced at the end. But when we code, we need to have a reference to it initially. So that's why we need to include IOStream at the top. We don't include stuff at the bottom, because we need to have stuff recognized before we use it. So we need to include our player.h in our main.cpp file as well. Alright, so how to create an instance or an object of a class. We have player, and let's call this player Joe. So we have a player called Joe. I'm going to lowercase that J. Open parentheses. That calls our constructor, so we need to give Joe 50 health. Semicolon. Alright, let's start printing out some stuff. See out quote Joe's initial health is Joe.getHealth and L. Alright, so we're going to print out his initial health, which should give us 50. Alright, now let's damage Joe. Joe.damage. And let's damage him by, let's say, 10. Joe got damaged. His health is now Joe.getHealth. Alright. let's heal Joe now. So we call Joe.heal, and let's heal him for 5. C out, 2 angle brackets, Joe is now healed. He now has, ending quote, double angle brackets, Joe.get health, double angle brackets. He now has how much health? Now, quote, space, and health. And let's add a, no, that's fine. And L. Alright. So now let's run this. Alright, so we set up Joe with 50 health. So Joe's initial health is 50. We damaged Joe for 10. Joe is damaged. His health is now at 40. That's good. We heal him for 5. Joe is now healed. He now has 45 health. So we're good. Now, you want to, check if it's, if you damage, you want to make sure it's a positive. Because if you damage with a negative, you instead heal him. Or if you heal with a negative value, you actually damage him. So you want to check for those. You can do something basic where if x is less than 0, return. You can do that. If x is less than 0, return. You can do that, or you can have it display message, or you can do whatever you want. But you want to do some checking to see what's appropriate. You wouldn't want a bank application to allow you to withdraw well, let me take that back. You wouldn't want a bank application to deposit a negative value, because that would mean you lose money. Now, I took that back because if you withdraw a negative value, you actually get more money, so you guys might actually like that. But you wouldn't want the other way, which is why I changed the order of that. Okay, so let's try to damage him again. Let's try to damage Joe with -5 damage. Alright, so Joe.damage, -5, semicolon. See out, angle brackets, quote, Joe is damaged with a negative value. His health is now, angle brackets, Joe.get health. Angle brackets and L. Joe's initial health is 50. We damage him. Let's do this. Joe got damaged for 10. Joe is now healed. Let's modify this. Joe got healed for 5. Alright. Let's see how that works. Alright, let's close that, and let's say Joe is damaged with a negative value of, with a value of -5. Alright, just so we can keep the process going. Alright, so Joe's initial health is 50. Joe got damaged for 10. His health is now 40. Joe got healed for 5. He now has 45 health. Joe is damaged with value of -5. His health is now 45. Which is what we want. If you're damaged with the negative value, you probably don't want to do anything, or you just want to display an error message, or whatever you want to do. But you want to be sure to check what is appropriate for that function and what's not. Obviously, the bank wouldn't like it if you withdraw a negative value because that will give you more money. You won't like it if you deposit a negative value and you lose money. So the same one with the player object, it wouldn't be right to damage with a negative value and get positive health in return. You wouldn't want to heal for a negative value and get lower health in return. Alright, so that's the introduction into classes. So we needed the header files to explain what the class is, what it has, what functions does it have, what, private fields, what variables, what pointers does it have. Everything that the class contains is in the header file. Actually, what the class does is in the CPP file. What does a constructor do? We know it accepts a health, but what does it actually do? What does the damage function do? It accepts a integer x value, but what does it actually do? So that's what is in the CPP file. We need to reference the header file whenever we want to use the object, use the class player, and use all of its functions and public accessible fields and variables if we want to use it. We use a header file for that because that's just here's what the class has. At the very end, everything is linked together, so we get all of our code. When we actually call that damage, it is running the damage code after we process the linker. But to recognize it at code time, at development time, we need to use a header file. I'll give you a brief example to get you to understand things a little bit better. After the main function in the main.cpp file, let's add a add int x, int y. Let's add a function called add that accepts an x and a y value. It returns an integer, so we return just x plus y. Okay, now you see that's actually in the main.cpp file. So let's do this. Cout, angle brackets, add, we're putting this in quotes here, add, let's say 3, 4, returns, ending quote, double angle brackets. Let's actually call the function add 3, 4. Angle brackets, end L. And you may have seen this in the video. I noticed this as I was processing it. I did this before, and you notice that there was an error that add was undefined. That's actually what we're going to get. Build, add identifier is not found. But it's there. Why doesn't it see it? This is why we need to include things at the very top of our CPP files. Because the way that C++ works is that it looks for things from top to bottom. Now, if the add function was before we used it, it would work. If it was before the main function, it would work. Add 3, 4, return 7. That is this line here. Add 3, 4, return 7. So we defined that function before we called it in main, so now it works. If we do that after main, it cannot find it. That's why sometimes if you look at code, you will see what is known as for declaration. So before main, we want to for declare our add function, int add int x, int y, closing parentheses, and semicolon. Hey, doesn't that look familiar? Look at our header file. So we for declare the add function. Now if we build it, we no longer have an error message. So it knows add exists, it just doesn't know what it does. Once everything is linked together, all the code is in place, that's actually where it knows how to process the add function. But it needs to know that it exists before we use it. So that's just another brief example on why we need to include header files and how the compiler works. So we need to include player.h. If we do not include that, obviously it won't know what's player. Player is undefined. Alright, now I hope you enjoyed this video. It's a pretty complex topic, but once you start learning it and once you start using it a lot, it gets easier. So just remember, CPP files have no knowledge of each other until the second part of compiling, which is the linker. Until everything's linked together, C++ files do not know that they exist. Now if you try to include a CPP file, you'll get all this linker errors. It's already defined an object, so if we do rebuild here, you'll still get these errors because it's already defined. So you want to include the header files, not the CPP files, because it will try to link it twice. It will try to build it twice. Think about include files, basically just parse what's in the file and include it in here. So this basically means that. But code maintenance at that point would be horrible, especially if we reference player in multiple places. We do not want to do that. If we change player to player object, if we change a class from player to player object, we'd have to change that everywhere we reference player. Or if we add a new function here, guess what? We need to change it everywhere we have a reference to player. So that's why we just include the header file, and that way we only have to change it once. So when we include something, it parses that file and includes it in the actual file. It actually does what it says. It includes this in its place. It parses that file and includes it here. As you see, if I build it, it succeeded. If I run it, it's the same thing. That's just like how we did for declaration of the add function a few minutes ago. It just needs to know that player exists and what the functions are, what the constructor is, what the private field is. So as you're coding, just remember, the program has to be aware of what you're using before you use it. That can be an include file, that can be a for declaration of a function that's below the function that you're using it, or you can just move the add function above the main function and use it that way. The code just has to be aware of the function or whatever you have before you use it. Take a look at one of my DirectX codes, for example. These are also called prototypes or for declaration of functions. Because generate window is after the win_main function, and that's where we use it, we need to for declare or set up a prototype for it. So the code needs to be aware of what you're calling, what you're using before you use it. Alright, this is a pretty long tutorial, so I'm going to stop it here. I hope you enjoyed it. It's been a few weeks since I've done a tutorial. I've been getting things ready, mostly for the artificial intelligence series. But I did a few other things as well, and there's also a game project I'm working on, so that's going to take a little bit of my time. So we'll be back to another tutorial next week, and we'll go from there. So I hope to see you next time. Thanks for watching. And if you have any questions, let me know. That's why I'm here. And I'll see you next time.